Good morning, dear students, and welcome to our new chapter, that is atom and molecules. Students, you all know it very well that matter is made up of small particles, and different matter have different properties. Okay, and these matters sometimes form in a group, and these are called molecules. Clear? So, different atom and molecules have different properties. So, and when these molecules atoms combine with each other, they form a new substance. So, the combination between two atoms, three atoms, they always form a certain law in which they have to specify them. Okay, now the first law is law of conservation of mass. See children, this law was given by Antoine Lavoisier. Okay, according to the law of conservation of mass, it states that mass can neither be created nor be destroyed in a chemical reaction. It means there is no gain or no loss in mass. Clear? Let us take an example to understand this. When carbon burns in air, it gives carbon dioxide. Okay? Now we will check that how can mass can neither be created nor be destroyed. Okay, the atomic mass of carbon is 12 and oxygen is 16. Okay, now there is carbon 12 plus 2 atom of oxygen, children. So 16 into 2. So 12, 16 2 ja 32, means it gives 44 gram. Clear children? Now we will check about this mass. Carbon 12. One thing children, you should remember that in chemistry, if there is different atoms are present in the compound, so there will be plus sign. Okay, oxygen is 16 into 2, 12, 32 is equal to 44 gram. Now it is clear children that the total mass of reactants is equal to total mass of product. Students, reactants means the substance which are going to combine with each other, they are called reactant. Okay, and the substance which form a result, the product which is result from this, that is known as product. So children, another law we can say that in other form means during chemical reaction, total mass of reactant should be equal to the total mass of product. Okay, let's take another example to understand more clearly. Now, see the question children. Sodium carbonate react with ethanoic acid. Okay. Sodium carbonate react means combine with ethanoic acid to form, means to give sodium ethanoate carbon dioxide and water. Okay, there will be carbon dioxide, children, comma carbon dioxide and water. Carbon dioxide and water. Okay, this is our statement. Means sodium carbonate react with ethanoic acid, which give sodium ethanoate, carbon dioxide and water. Now in an experiment, 5.3 gram of sodium carbonate, the mass of sodium carbonate is 5.3 gram, reacted with 6 gram of ethanoic acid. 6 gram of ethanoic acid. So we can write 6, children, which gives 8.2 gram of sodium ethanoate. Means mass of sodium ethanoate is 8.2 plus carbon dioxide, means 2.2 gram of carbon dioxide, and water, means 0.9. So these are reactant, children. These are reactants and these are product. Now we have to verify that this equation follow the law of conservation of mass. So earlier, children, I have explained you that law of conservation of mass states that total mass of reactant must be equal to the total mass of product. It means there will be no change in mass during a chemical reaction. Okay, now calculate 6, 5, 11, means 11.3 gram of reactant, which gives, now add, children, 8 to 10, 10, 1, 2, 4, 4, 9, 18, 13, 11.3 gram of. So children, you can check it, both mass are same, means there is no change in mass during a chemical reaction. It means this equation follow the law of conservation of mass. Clear, children? Now second law is that law of constant proportion. Okay, students, constant means which never change and proportion means their ratio. So this law was given by Proust. Okay, this law was given by the scientist name is Proust. According to the law of constant proportion, he stated that every pure compound contains the same element. Okay, contains the same element and combined in the same ratio by mass. Okay, children, every pure compound, we all know it very well that compound is always regarded as pure. Okay, every pure compound contains the same element. It means, children, wherever you will take water, okay, either from pond, either from lake, either from a river, they all contains hydrogen and oxygen atom. Means whenever you will take water either from pond, lake, river, sea also, they all contains one atom is hydrogen and second atom is oxygen. It also contains one atom of hydrogen and second atom is oxygen. Means every pure compound contains the same element. Clear, children? And combined in the same ratio by mass. Means when we calculate the ratio by their mass, it will remain same. Now see, children. Atomic mass of hydrogen is 1 and oxygen is 16. When you calculate the ratio of water by mass, means there is 2 hydrogen, children, so 1 into 2 ratio, oxygen 16, 2 and 2, 16. Write its simplest form, 1:8. Means every water compound contains the hydrogen and oxygen atom and combined in the ratio of 1:8. Means 1 part of hydrogen and 8 part of oxygen. Clear, children? It does not depend upon any source. Okay? Now note in your copy. Let's take another example to verify law of constant proportion. When carbon burns in air, gives carbon dioxide. Okay? And now calculate its ratio, children. Mass of carbon is 12 and oxygen is 16. So the ratio of carbon dioxide will be 12:2. There is 2 atom of oxygen, so 16 into 2, 12:32. Means write in simplest form, 4 3 is 12, 4 8 is 30. Means when carbon burns in air, it gives pure compound carbon dioxide, which is in the form of ratio 3:8. Means it is made up of 3 part of carbon and 8 part of oxygen. Okay? Now first method, this is the first method to obtain carbon dioxide. Second method, when carbonic acid break down, it gives H2O and CO2. There is also a formation of carbon dioxide, but we have obtained this carbon dioxide from other method. Okay? Now compare the children, both carbon dioxide. Both compounds are carbon dioxide. This is also carbon dioxide. And both compound contains the same element. Means it also contains 1 carbon. It also contains 1 carbon. There is 2 atom of oxygen. There is 2 atom of oxygen. And now calculate its ratio. And now calculate the ratio of this carbon dioxide. Atomic mass of carbon is 12 and oxygen is 16. So there is 2 atom of oxygen, 16 into 2, 12, 32, 4 3 is 4 8 is. Now compare with this, children. Both their ratio are same, their element are same, but we have obtained this compound from other method. Okay? It means, children, every pure compound contains the same element. It does not depend on any source where you have obtained the compound. So every compound contains the same element and combined in the same ratio by mass. Concept clear, children? Now, children, Dalton's atomic theory. Means Dalton's gave some theory on atoms. Let us take an example to understand this. If we take a chalk, children, and break it with other substance, we get small pieces of chalk. Again, beat it, children, you will get a small pieces. So if you do this activity a number of times, at last we will get a very small particles, and these small particles are called atoms. Okay, so children, on the basis of these observation, John Dalton was a British scientist. He gave some postulates over the atoms. Okay, now see children, first, all the matter is made up of very small particles are called atoms. Means all matter consists of very small particles, and these small particles are called atoms. Atoms cannot be divided, being a very small. That is why he stated that atoms cannot be divided. Atoms can neither be created nor be destroyed. Fourth, all atoms of an element are identical in terms of mass, size and other properties. Means all atoms which are found on the earth are identical either in terms of mass, size or properties. Fifth, atom of one element they can differ in mass and other characteristics from other elements. Clear? 6. Chemical combination results in the union of atoms in numerical proportion to form large number of compounds. It means two or more atoms combine to give a new substance. Clear children? But as the time passes, new scientists gave a new theory on the atomic and on atoms. So there is some drawbacks about this John Dalton's atomic theory. Clear? Now we will see that what were the drawbacks about these postulates. Okay. Now children, see the drawbacks of John Dalton's atomic theory. First children, Dalton stated that atoms can neither be created nor be divided. Means it cannot divide it. Okay. But children, at the end of 19th century, it was found that atom can be divided. Atom can be divided into subatomic particles called electron, proton and neutron. This was the first drawbacks of John Dalton's atomic theory. Clear children? Second, he stated that atoms of same element are identical in terms of mass. But children, there are also some elements in the nature which have different masses. For example, atom, we can write atom of same element have different mass. Example children, chlorine, atomic number 17, atomic number 17, but the atomic mass is 35 children and 37. Clear? Dalton stated that atoms of same element have identical, means they have same atomic masses. But children, there are some elements which are found in the nature, they have different masses. For example, chlorine, carbon also children, 6, 12, 6, 14. Same element, but they have different masses. Okay, and this type of atoms or elements are called isotopes. Clear children? When same element so different masses, these type of element are called isotopes. Third is atoms of different element have same mass. John Dalton stated that if atom is different, then their mass, size and property will also different. See children, there are also some elements found in the nature being different, they show a same masses. Clear children? For example, potassium and argon, 40, 19 and 40. Both are different element, but they are showing same masses, and these type of element are known as isobar. Clear children? Those elements which being different, if they show the same masses, these type of element are called isobar. So children, these are the drawbacks of John Dalton's atomic theory. There will be calcium children. Calcium atomic number 20, 40. Okay, we will take different element and they are showing different mass. So when these different elements show a same mass, they are called isobar. And when the same element show different mass, they are called isotopes. One also drawback is there children. Fourth drawback is that John Dalton stated that two or more atoms combines to give a new substance. Okay, but children, he could not explain that how these element combine to form new substance. Okay, he could not explain that how these atoms or elements combine and why do they combine to form a new substance. Clear children? So these all are the drawbacks of John Dalton's atomic theory.